morning all. So in last class we were looking at linear system of equations and how to solve for first order linear system. So in today's class we will look at the famous example of a nonlinear system which is called as the Volterras Predictor equation. So it is one of the famous equations in ecology. So we will see how this particular equation is formed, and it is an example of a nonlinear system of first order. And the predator-prey equations is associated when you have a problem where you find the population. So it is an equation which tells you about the population, and where you will be looking at the population of two species where the species are interrelated. Rather, one of the species will be surviving on the depending on the number of the other species. So one will be eating the other. That is the kind of species we have. So we can take any two species such that they are interdependent on one another. Okay. So here we will be mainly looking at two species. So we will be taking the example of foxes and rabbits. So as you know, the foxes are predators. So they will be eating the rabbits. So here the rabbit is called the prey. We will be taking a system where one kind of the animal survives by eating another, and a second by developing methods of evasion to avoid being eaten. So we will be taking the example of foxes, where the foxes will survive by eating the rabbits, and the rabbits will find their own methods to be avoid being eaten by the foxes. We make the following assumptions. So the foxes will be eating rabbits, and the rabbits are eating clover. So clover is some kind of plant. Rabbits steady so that is called the clover. So we assume that the rabbits have an ample supply of food. So the rabbit always have ample supply of food. അതുകൊണ്ട് റാബിറ്റിന്റെ പോപ്പുലേഷൻ എപ്പോഴും റെഗുലർ ആയിട്ടായിരിക്കും. അതായത് അതിന് എപ്പോഴും നമ്മൾ ആംബിൾ സപ്ലൈ ഓഫ് ഫുഡ് ഉണ്ട്. അപ്പോൾ നമുക്ക് അങ്ങനെ അതിന്റെ പോപ്പുലേഷൻ ആ എമൗണ്ട് ഓഫ് ഫുഡിനെ ഒന്നും അഫക്റ്റ് ചെയ്യുന്നുള്ളൂ. സോ ദാറ്റ് ഇസ് എ assumption we are taking. Now we will see how does the problem arise, or how do we formulate the equation. ഇനി നമ്മുടെ പോപ്പുലേഷനിൽ ഫോക്സസും ഉണ്ട്, റാബിറ്റ്സും ഉണ്ട്. Now since the rabbits have abundant supply of food, they will have the food and they will grow in population. ഇനി റാബിറ്റ്സിന്റെ പോപ്പുലേഷൻ കൂടുന്നതിനനുസരിച്ച് so foxes are the predators, so they will be eating the rabbits. അപ്പോൾ റാബിറ്റ്സിന്റെ പോപ്പുലേഷൻ കൂടുതലായതുകൊണ്ട് ഫോക്സസിന് കൂടുതൽ റാബിറ്റ്സിനെ കൺസ്യൂം ചെയ്യാൻ പറ്റും. So when the number of rabbits increases, the foxes will get to consume more number of rabbits, and the population of foxes will flourish. So when the rabbits are abundant, so the foxes will flourish. Now that means their population will be growing. ഇനി ഇപ്പം റാബിറ്റ്സിനെ കൺസ്യൂം ചെയ്ത് ഫോക്സസിന്റെ പോപ്പുലേഷൻ കൂടും. ഇനി stage will reach when the population of foxes keeps on increasing. അപ്പോൾ ഫോക്സസിന്റെ പോപ്പുലേഷൻ ഒരു പരിധി കൂടുതൽ കൂടിക്കഴിയുമ്പോൾ അത് ഈ റാബിറ്റ്സിനെയാണ് കൺസ്യൂം ചെയ്യുന്നത്. അപ്പോൾ അതിനനുസരിച്ച് റാബിറ്റ്സിന്റെ പോപ്പുലേഷനിൽ കുറവ് വരും. സോ സ്റ്റേജ് വിൽ കം ലൈക്ക് something of the sort of a family. That means the foxes, since there are large number of foxes, they will be in short of supply of rabbits, so their population will start to decline. So foxes numerous ആവുന്നതിനനുസരിച്ച് they will eat too many rabbits, and they enter the period of famine, and the population begins to decline. So such a situation will come. അപ്പോൾ ഫോക്സസിന്റെ പോപ്പുലേഷൻ ഡിക്ലൈൻ ചെയ്യാൻ തുടങ്ങും. അപ്പോൾ ഫോക്സസിന്റെ പോപ്പുലേഷൻ ഡിക്ലൈൻ ചെയ്യുമ്പോൾ the rabbits then become relatively safe, and their population will start increasing. So as a fox's population decrease, so the rabbits will start growing. So rabbits in the population പിന്നെയും കൂടാൻ തുടങ്ങും, and this will again bring back the same situation. അപ്പം ആദ്യം നമ്മൾ സ്റ്റാർട്ട് ചെയ്തത് റാബിറ്റ്സിന്റെ പോപ്പുലേഷൻ കൂടുതലായിരുന്നു, അതിനനുസരിച്ച് ഫോക്സസിന്റെ ഇൻക്രീസ് ചെയ്യാൻ തുടങ്ങി. അപ്പോൾ വീണ്ടും നമ്മളിവിടെ rabbits population increase ചെയ്യുമ്പോൾ again there will be an increase in the population of foxes, and this cycle keeps on continuing. Okay, so that is our problem. Okay, so the number of rabbits and number of foxes are interrelated, and the population keeps on increasing and decreasing with respect to one another. Now when we model this equation, or when we model a problem of this kind, the equation we obtain is called the Volterras Predictor equation. So here we have taken a specific example of foxes and rabbits. So you can change it by any kind of species where the populations are interrelated. So such a problem is called the Volterras Predictor equation, and this is one of the most important problems in the nonlinear system of equation, and it is one of the important problems in mathematical ecology. Now we will see how to formulate this problem as a nonlinear system of equations. So for this we will denote x by the number of rabbits at time t, and let y denote the number of foxes at time t. And let me take the assumption that at the time t equal to 0, so we start with 0 number of foxes. So at so let me take x to be the number of rabbits at a time t, then dx by dt denotes the change in the number of rabbits. So dx by dt will be directly proportional to the number of rabbits. So this is the increase in the population of rabbits. So rabbits in ample supply of food allowed, rabbits in the population increasing again. That's what we said first. So dx by dt will be directly proportional to x. Now let me take a to be the constant of proportionality. So since there is an unlimited supply of food, the number of rabbits will keep on increasing. So dx by dt will be positive. So we will have dx by dt equal to ax, where a is greater than 0. So dx by dt is equal to ax since there is an unlimited supply of clover. Now let us take the number of foxes to be 0 initially. So this will be dx by dt. And now let us look at the encounters. Now the number of encounters are interrelated. Now when an encounter happens, so the rabbits will be consumed by the foxes. So the population of the change in the population depends on the number of foxes also. അപ്പോൾ number of rabbits എത്രയുണ്ട്, number of rabbitsന്റെ എണ്ണത്തിനനുസരിച്ചായിരിക്കും അവ തമ്മിലുള്ള interactions വരുന്നത്. Okay, so if we assume that a certain proportion of encounters result in a rabbit being eaten, then we will get dx by dt equal to ax minus bxy, where a and b are greater than 0. So this is the change in the population of the rabbits. So initially there will be these many, this will be the number of rabbits you have. So this will be the number of increase in the rabbits, and when there are interactions between the rabbits and foxes, some of the rabbits will die. So we need to subtract that. So the growth rate will be ax minus bxy. Now we take a product of x and y because the number of rabbits which die depends on the number of foxes are there. So എന്തോരം rabbits die ആവുന്നുള്ളത് എന്തോരം foxes ഉണ്ടെന്നും കൂടി അനുസരിച്ച് ആ നമ്പർ ഡിപ്പെൻഡ് ചെയ്യും. So we will get dx by dt to be ax minus dy, where a and b are greater than 0. Now, in the same way, we said that ഇപ്പോൾ റാബിറ്റ്സിന്റെ പോപ്പുലേഷൻ കൂടും, റാബിറ്റ്സിന്റെ പോപ്പുലേഷൻ കൂടുന്നതിനനുസരിച്ച് റാബിറ്റ്സും ഫോക്സസും തമ്മിലുള്ള ഇന്ററാക്ഷൻ കൂടും. സോ ദാറ്റ് വിൽ ഇൻക്രീസ് ദി പോപ്പുലേഷൻ ഓഫ് ദ ഫോക്സ് സിംപ്ലർ. ഇനി ഫോക്സസിന്റെ പോപ്പുലേഷൻ ഇൻക്രീസ് ചെയ്യുമ്പോൾ അതിനനുസരിച്ച് റാബിറ്റിന്റെ പോപ്പുലേഷനിൽ കുറവുണ്ടാവും. സോ നൗ ലെറ്റ് us look at the change in the population of the foxes. So change in the population of foxes. Now when there are more interactions between the rabbits and foxes, ഫോക്സസിന്റെ പോപ്പുലേഷൻ കൂടുതലാണ് ചെയ്യുന്നത്. മോർ ഇന്ററാക്ഷൻസ് ഉണ്ടാകുന്നതിനനുസരിച്ച് മോർ റാബിറ്റ്സിനെ കൺസ്യൂം ചെയ്യും, അതിനനുസരിച്ച് ഫോക്സസിന്റെ പോപ്പുലേഷൻ കൂടും. സോ വി വിൽ ഗെറ്റ് പോസിറ്റീവ് ടേം dxy. Now when the population of rabbits decrease, there will be a gradual decrease in the population of foxes. So you will have minus cy എന്ന് പറയുന്ന ടേം വരും. So in the absence of rabbits, the foxes will die out, and their increase will depend on the number of encounters with rabbits. So the increase depends on the number of encounters with rabbits, which is denoted by the term dxy, and in the absence of rabbits, the foxes will die out, which is denoted by the term minus cy. So we have c and d greater than 0. So these two set of equations is a nonlinear system describe the interaction of these two species. So this system of equation is famously known as the Volterras predictor equation. So we will get dx by dt. So we have taken x and y outside here. So we will get x into a minus dy and y into c minus y into c minus dx. So these equations are called the predictor equation. Since there is this product of x and y, this is a nonlinear equation, and this cannot be solved in terms of the elementary functions. അപ്പോൾ നമുക്ക് ഫംഗ്ഷനും ഡെറിവേറ്റീവ് ഫോമിലാണ്, ലീനിയർ ഫോമിലാണെങ്കിൽ we can use the elementary function, അതായത് പോളിനോമിയൽസ് അല്ലെങ്കിൽ എക്സ്പോണൻഷ്യൽ ഫംഗ്ഷൻ ഡയറക്ട്ലി രണ്ട് സൈഡിലും സാറ്റിസ്ഫൈ ചെയ്യുന്നതാണ്. നമ്മൾ ലീനിയറിന് എടുത്ത പോലെ നമുക്ക് ചെയ്യാം. ഓക്കെ, so here there is no possibility of such a solution since we have a nonlinear system. Now let us simplify this equation. So we will think of a solution of the form x equal to x of t and y equal to y of t. Now from equation 1, when you eliminate eliminate t, we will be getting so we will get dx by, so I can find dt from both the equations. So we will be getting dx by x into a minus by equal to dy by minus y into c minus dx. Equations random equate ചെയ്യുമ്പോൾ we will be getting an equation of this form. Now that can be that will be in the variable separable form. For integrating on both sides, we will get a relation of this form. So this is a by y minus b dy equal to minus c by x plus d dx. Upon integrating, we will get a log y minus by equal to minus c log x plus dx plus let me take the arbitrary constant to be log k. So this can be rewritten as y power a e power minus by plus k x power minus c e power dx, where k is a constant. Now let us take the initial population to be x equal to x naught and y equal to y naught. So that will give the value of k to be x naught power c, y naught power a, then e power minus dx naught minus d y naught. So instead of getting an explicit solution of the form x equal to x of t, y equal to y of t, we will obtain the solution to be a relation connecting x and y. So this is one of the ways of formulating the solution of Volterras equation.